Hello students, I'm Vinayak from channel Physics Adda. This is class number 2. Today we will be solving another 5 questions which was asked in previous NEET examination. So let's start. Question number 1. You can read the question and you can pause the video and try to attempt the question. Okay, I will solve the question. This question was asked in NEET 2015. So for solving this question, you need to understand the concept of constrained motion. Okay, constrained motion. What is the question? We are having three blocks A, B, and C. A, B, and C of mass 4 kg, 2 kg, and 1 kg respectively. They are in contact on a frictionless surface. Means here mu is equal to 0. There is no friction. If the force of 14 Newton is applied on 4 kg block, and if this is 4 kg block, this is 2 kg block, and this is 1 kg block. Here I am applying force of 14 Newton, then I need to find the contact force between A and B. What is the concept? Contact force. What is contact force? What is contact force? If I am having a block like this, and if this block is moving in right direction, in towards right, then the surface will execute normal reaction perpendicular to the surface on the block, whereas friction will always act opposite to the direction of relative motion. If my observer is standing over here, is stationary, velocity of observer is 0, then you will find that this block is moving towards right and frictional force will oppose the relative motion, so it will act towards left, right? And contact force will be what? Both are contact forces, friction as well as normal reaction. So if they make an angle theta, F makes angle, if this is N and if this is F, they makes angle of theta with each other, then as per vector algebra, the contact force will be square root f square plus n square plus twice fn cos theta, right? But here this f is 0. Okay, so the only force be which will be providing component of contact force will be normal reaction. Okay, normal reaction. So let us solve the problem. Let us solve the problem. I'm having 4 kg, 2 kg, and 1 kg block. This is 4 kg, this is 2 kg, this is 1 kg, this is 14 Newton force. Then I can consider this whole as a single system. Then I will find acceleration. Observer is standing here, velocity of observer is 0, he is stationary, so we will find that the whole system is moving towards right. Okay, so it is moving towards right with acceleration A, then the what is the value of A? This I will apply horizontal equilibrium. So in that case, over this block, so mass will be 4 plus 2 plus 1 is 7 kg. Horizontal equilibrium will give m7 into A is equal to 14. A will be 2 meter per second square. Okay, this A will be 2 meter per second square. Now, if all three blocks are moving with with acceleration 2 meter per second, then individual blocks will also move with acceleration 2 meter per second square, right? And here also 2, I need to find the normal reaction between A and B only. Okay. So in this case, B will impart normal reaction on A, right? In this direction, and acceleration will be in right. Acceleration will be towards right. So mass of block A into acceleration is equal to, what is the force towards right? 14. What is the force towards left? And normal reaction, and this will be on N on A by B, right? So if this MA is 4, this is 4, this is 2, is equal to 14 minus NAB. So this is what? 8. So NAB will be 14 minus 8 is equal to 6 Newton. What is the answer? The answer is 6 Newton. So the right option is D. Question number 1, answer is D, 6 Newton. Let's move to the next question. Question number 2. So here you can see we are having a block of mass m1. We are having a block mass m1. I'll draw the block first. This is the surface, and I'm having block of mass m1. Here mass is m1. Okay. Now this block is tied. This block rests on horizontal table, and a light string is attached to it. A light string is attached to it like this, and it passes over a frictionless pulley. This pulley is frictionless, means mu of pulley is equal to 0, and this is pulley P at the edge of the table, and here the pulley is attached, and from its other end another block of mass m2 is suspended. So here I am having block B, this is block A. Okay. The coefficient of kinetic friction between block and surface is mu k. Here mu k is the coefficient of kinetic friction. Then when the block A is sliding on the table, the tension in the string will be what? So this is the tension unit. Tension always acts away from the block T. Here it will act away from the block B, that is T. Since string is same, the string is same, tension will be same throughout the string, right? So if I'm solving this problem, this if my observer is standing here, the velocity of observer is 0, and you will observe that the mass m2 is moving downwards with acceleration in right. This mass m1 will move towards right. The acceleration high. Okay. Can you imagine the situation? This m2 is moving down, and since this is moving down, the string will pull mass A or mass m1 towards right. Okay. I need to draw separate free body diagrams for block A as well as block B, right? If I'm drawing the FBD for block B, then what are the forces acting on block B? This is M2G, force due to gravity, and tension will be T. Now relative motion is downwards. So this M2 into A will be force in the direction of motion, that is M2G minus T. So this is my equation number 1. Now what is the equation number 2? This is I am taking vertical equilibrium. Then I will be getting equation number 1 on block B. Okay. Now I need to consider the other case of block A. which is resting on surface, right? Here I am having pulley like this. So this T will act away from the block and the motion is towards the right. If observer is standing here and observer is stationary, okay, stationary observer, then friction will be acting towards left. Why? Because friction is having tendency to oppose the relative motion. Again, the word oppose is very important. Having tendency to oppose the relative motion, or it opposes actual relative motion. Here we are having kinematic friction. This force is this block is moving, so we'll be having kinematic friction. So if I'm taking this will be what normal reaction N, and force due to gravity will be towards. What is the force due to gravity? It will act downwards. So the block A is having mass m1, so this will be m1g. The force due to the weight of block A. Now if I am taking vertical equilibrium, then this N will be equal to m1g, and if I am taking horizontal equilibrium on block A, then mass of block A, that is m1A, is equal to, what is the force towards right, that is towards in the direction of motion, that is T, and to the left is F, frictional force. So I know that in case of kinetic friction, which is a constant, F is equal to mu k into N, right? So this T minus mu k into N is equal to m1n. This will be my equation 2. What is equation number 1? What is equation number 1? Equation number 1 is m2a is equal to m2g minus t. m2a is equal to m2g minus t. This is equation number 1 we have got for block A and for block B, and this is for block A. So if I am adding both equations, if I am adding, this is m2a is equal to m2g minus t. If I am adding both equations, equation 1 plus equation 2, I'll be getting m1 plus m2a is equal to, this t gets cancelled, and this becomes m2g minus mu k into n. This will be m2g minus, what is the value of n for vertical equilibrium? m1. This will be m1g into mu k, right? So finally I'll be getting, if I'm taking g outside, I'll be getting m2 minus m1 into mu k is equal to a is equal to g into m2 minus m1 mu k divided by m1 plus m2. This m1 m2 I'm taking towards right in the denominator. Then a becomes g into m2 minus m1 mu k divided by m1 plus m2. See here, I've been asked tension in the string, not the acceleration. Okay, not the acceleration. So what is the tension? Tension I can calculate from here, from equation number 1. I can put the value of A in equation number 1. So T is equal to m2g minus m2a. So this m2 I will take outside, so this becomes g minus a in the bracket. So T becomes m2 into g minus, this is, I will put the value of A from equation number 3, G into M2 minus M1 mu K whole divided by M1 plus M2. So this becomes M2. If I try to simplify this bracket, this M1, M2, I will take it here. So this is, if I'm taking G outside, then this becomes M1 plus M2 minus M2 plus M1 mu K divided by M1 plus M2. So this becomes, this M2 M2 gets cancelled, and this M1 I can take outside. This becomes M1 M2 into M1 M2 into 1 plus mu K, 1 plus mu K divided by M1 plus M2 into this G. So what is the right answer? Right answer is D. Right answer is A. M1 into bracket 1 plus mu K into G divided by M1 plus M2. Okay. Let's solve problem number 3. So you can pause the video and you can try to attempt the question. So here we have been given a pulley system. Now a system consisting of three masses M1, M2 and M3. Here M1 is equal to M2 is equal to M3 is equal to M. All three masses are equal. Okay, they're connected by a string passing over pulley P. This is passing over pulley P. The mass M1 hangs freely. The mass M1, okay, this is M1, this is M2 and this is M3. Okay, mass M1 hangs freely. M2 and M3 are on rough horizontal table. This table is rough. So frictional coefficient is mu. The pulley is frictionless. So friction mu p is equal to 0 and of negligible mass. Mass of pulley is also 0. The downward acceleration of mass m1 is what? It is the downward acceleration of mass m1. Okay, I have been asked what is m. Okay, so you can see we are having three masses. If I consider this as a system, this as a single mass, so it will be what? M2 plus M3 is equal to 2m. Both are having same masses. What is the force acting on this block? We need to find out. Okay, so if I'm considering equilibrium over here, what are the forces acting on this system M2 plus M3? There, since this surface is rough, this is a rough surface, frictional force will always act opposite to the direction of relative motion. If my observer is standing here, then the velocity of observer is 0. Then you will observe that this m1 is going down and this m2 plus m3, both masses are moving to the left. Okay, to the left. So friction will act opposite to the direction of motion F. So this acceleration A is towards left and frictional force F is towards right. Okay. What is the normal reaction? It will act perpendicular to the surface. Perpendicular to the surface. So this will be N and this will be 2mg. So if I am taking vertical equilibrium for M2 and M3, M2 plus M3, then it will be N is equal to twice mg. Okay, Second, if I am taking horizontal equilibrium for M2 plus M3, I'll get mass, that is twice M into A, is equal to this will be T away from the block, tension T away from the block. So this will be force in direction of motion, that is T, minus opposing the force which is opposing the motion, that is frictional force F. We know that T minus F is what? Mu into N, right? What is the value of N? That is 2 mg, so this is will be 2 mg. So final equation will be what? 2ma is equal to T minus 2ma is equal to T minus twice mu into M into G. So this is equation number 2. Okay. Now I need to consider the block which is moving down. I need to consider this block. Okay. What are the forces acting on this block? Tension T upwards, motion is downwards, and the weight of the block will be acting downwards. So this will be mg. So I will draw free body diagram. This is m. This will be acting downward. Motion is downwards, and tension force will be upwards. So m into a is equal to what is the force in the direction of relative motion? If my observer is standing here, V observer is 0, then MA is equal to mg minus T, right? mg minus T. So this is equation number 3. If I'm adding equation number 2 and 3, I'll get twice ma plus ma is thrice ma, 3ma is equal to T gets cancelled, and this becomes mg minus twice mu mg. So this mg I will take it common, 1 minus twice mu is equal to 3ma. So mm gets cancelled, and a is equal to g into 1 minus twice mu by 3. Okay. So what is the right answer? Right answer is this one, g bracket 1 minus twice mu by 3. Okay. So let's solve the next problem. Now you can pause the video and try to attempt the question. Okay, I'll solve it. This question was asked in NEET 2014. The previous question was asked in NEET 2014. Okay, that I forgot to mention. So here you can see we are having a balloon of mass m. Okay, balloon is having mass m, and it is descending down with acceleration a. Descending down with acceleration a, which is less than g. Okay, how much mass should be removed from it so that it starts moving up with the acceleration? Now here, in all the problems we have discussed so far, the mass was constant. Okay, mass was constant. But here the mass is not constant. Mass is not constant. We have removed some mass. So let us solve it like this. So before removing mass, the downward force will be mg, that is weight of the balloon. Okay, and upward force will be what? Here they are not. There will be air resistance, and they have not mentioned that air resistance is negligible. Here there will be air resistance, that is thrust force, which will be F thrust force. So if I am considering vertical equilibrium before removing mass, so it will be m into a is equal to what is the force in the direction of motion. If my observer is standing here with velocity 0 or observer is stationary, then as per Newton's second law of motion in vertical equilibrium, ma is equal to mg minus f thrust force acting upwards. If I'm removing some mass, okay, I'm removing some mass from the balloon, it becomes small. So if I'm removing x kg from balloon, from balloon. So what will be the mass of balloon now? M minus x kg. Here they have mentioned that when the mass is removed from the balloon, it starts moving up with the acceleration a. With the same acceleration, it will start moving up. Initially, it was moving down. Now, the acceleration has remained same, but its direction is opposite to the earlier direction of acceleration. See, here, will it be the same? This A and this A is same? No, because we have studied in the vectors that even though the magnitude of two vectors is same, it is not necessary that both vectors are equal. Okay, vector is quantity, physical quantity having direction as well as magnitude. So for two vectors to be equal, direction as well as magnitude both should be equal. Okay, so the downward force acting on the balloon after removing x kg will be m minus x into g, which is the weight of the balloon, and f thrust. This will act in upward direction. So now this vertical equilibrium will be, you consider this as equation number 1. Vertical equilibrium will be m minus x into a is equal to f thrust minus m minus x into g. Okay, now I will add equation number 1 and equation number 2. So I'll get ma plus m minus x into a is equal to f thrust gets cancelled, mg minus m minus x into g. Okay, so this becomes twice ma minus x into a is equal to this mg minus mg gets cancelled, and this becomes m in x into g. Minus minus becomes plus, so this becomes x into g. The equation is twice ma minus xa is equal to twice ma, so I will write it here, 2. Now I'll write it here. This becomes twice ma is equal to, I'll take x common and this becomes a plus g. I'm taking this term towards right hand side. So this x becomes twice ma divided by a plus c. This is the amount or quantity of mass removed for the balloon to move in the upward direction with acceleration a. Okay, so what is the right option? What is the answer? Twice ma divided by a plus g. So the right option is option number A. Okay, option number A. Next problem. This is very easy problem. This is very easy problem. See, this force is, you can pause the video and type in the problem. So this force is F. F is applied on the block, and we are having three blocks of masses m, 2m and 3m, which are connected by a string. Now the masses move upward. Here they have said masses move upward. If this is the observer who is stationary observer, its velocity is 0, you'll find that the masses are moving upward with acceleration a, say, and speed equal to v. Now you have, there is one important term over here in the problem. Sometimes if you read the problem carefully, the problem itself will give you the solution. You don't need to solve the problem. Okay? This is constant speed. So what is acceleration? dv by dt, derivative of velocity. If v is constant, it means that a will be 0. So do I need to solve the problem? What is the net force? What is the Newton's first law of motion? First law, it states that if a is equal to 0, then F net will be what? 0. So, but they have said that what is the net force on the block 2m? This 2m. It will also be 0. The answer is C. Okay, this will also be 0. How come? This is F net on whole system. This is F net on whole system. Okay. This is 0. I'm saying since A is 0. But I'm saying this will also be 0. On this block will also be 0. On block 2 will also be 0. How come? Because this block will move upward, will be pulled upward with force 5 mg, and it will be pulled downwards with force 5 mg. So the net force will be 0. How come? I'll tell you. Let's solve the problem. We'll go by our usual method of solving the problem. I will draw FBDs for individual blocks. Okay. For individual blocks. This is F. So this will be 3 mg acting downwards. Now this string is same. Let us say tension T will be acting away from the block 3m. So this will also be T. And string is same. This is T1 for this string. This will be T1. So since here A is 0, so what will be equation vertical equilibrium for block 3m? Vertical equilibrium will be 3m into A. Now here A is 0 is equal to T minus this force T in the direction of motion, T minus 3 mg. Okay, so this becomes T is equal to 3 mg. So this will be what? 3 mg. So this will also be 3 mg. Now for this block, what is the value of F? I need to find out. I need to find out the value of F. Okay. Now you can see that I can combine the masses of, tension will be resolved internally over here, and I can consider this as a single block of mass m plus 2m plus 3m will be 6m. So downward force will be 6 mg, and this is F. Upward force or applied force, if motion is in upward direction with constant speed, So A is equal to 0. So for this block 6m into A, which is 0, is equal to force in the direction of motion minus 6 mg. So this F will be what? 6 mg. This will be 6 mg. Okay, if this is 6 mg, then block M, this is 6 mg force acting upward, this is 6 mg, and this is tension T1. And this is moving upward with acceleration A is equal to 0 and speed V, then this mass into A, which is 0, is equal to 6 mg minus T1. Also there will be a downward force mg acting on the block M due to its own weight. Okay, so this will be T1 plus mg. So T1 will be what? 5 mg. This will be 5 mg. Now, now we will solve the problem for block 2m. For block 2m, I need to remove this one. Okay, 2m. If this is block 2m, so this will be 2 mg acting downwards due to its own weight. This is tension T. T is equal to 3 mg. Okay, T is equal to 3 mg. Is there any other force? Is there any other force? Yes, there are some other forces acting on the system. This is upward direction, tension T1, which is also 5 mg. What is the net force on block? Net force on block 2m will be forces in the direction of motion. Motion is in upward direction with velocity v and acceleration is equal to 0. So net force on 2m will be T1 in the direction of motion minus T plus twice mg. What is the value of T1? Is 5 mg. What is the value of T? It's 2 mg, or it's 3 mg. This is 3 mg. So this 3 plus 2 is 5 and here is 5. 5 minus 5 is 0. So answer is 0. So answer to problem number 5 is C, 0. So again I am telling you, you can solve some problems by just reading the statement of the problem carefully. Once they have said that there is a constant speed, it means that as per Newton's first law of motion, the net force will be 0. So thank you and stay tuned for the next video. See you again. Goodbye. पढ़ो और आगे बढ़ो. Thank you.